Okay, next step is to find the velocity, final velocity at 10 meters. And again, we are going to use the energy conservation method first. So for the energy conservation method, we are just not going to write down what the equation is. And this is a little different than what the equation sheet shows. And for the next exam on April 1st, I'm gonna add one more equation. It's really same thing, but it's more general because we don't know this much specifics yet. So we will be using in this form. Just gonna make it a little bigger, it's easier to write this way. Delta K plus delta U plus delta I equals to work done plus heat. Okay, so this is our equation. If you look at the equation sheet that I provided, there are more than one delta K, more than one delta U, more than one delta I. So we are gonna look into those in more specifically, but this is the combined version. Okay, so there you have like 5 terms in this. And so first thing we do is to simplify. So I'm going to think about do I have any 0 terms here. Let's think about that first. Do I have a change in speed? And yes, and I'm trying to find the speed, so delta K is going to stay here, right? What about change in elevation? If it is not horizontal, then I will have delta U unless I want to use that as the work done by the weight force on the right side. I usually keep delta U in, but in this problem, again, I'm going to show you right here again. I can do either because I already have both of them. I know what delta U is. It's positive 7,358 joules, or I have the work done by the weight force. It is negative 7,358 joules. One or the other doesn't matter because I've already collected everything, all the information. But in general, especially if they're not asking you to find the work done by the weight force, I think it's easier to keep delta U in and then kind of ignore the work done by the weight force on the right side as the work term because you already accounted that for in the potential term. Okay, so that's the practice we need. So I'm keeping delta U because there's a change in elevation. What about delta I? That's going to go to 0, right? And let's explain why. Again, no change in temperature T or pressure P. So molecular level, that we don't have any change, okay? So we're trying to write that down. And work terms is something we skip and look closer in the next step. Heat is also 0 because there's no heat added or subtracted. Okay. Okay, so we cleared up a little bit. Next step is working on that weight force. Sorry, I always confuse W's as well, like work done. So what is work done? Looking at our free body diagram, work done has 2 terms. There are 2 forces, tension and weight force. Even though you don't account them for, or they're already, you know that they're 0, write them down and explain why. So like show your work, okay? This is going to be very important in the exam as well. So the tension work done, we already have it, right? We just found it in part A. And work done by the weight force, we already have it as well. But remember, I kept delta U. Maybe I want to get rid of this work done by the weight force. You can do either way though. I really want you to be clear on that. And if it is not clear, please reach us through discussions for Monday's class or emails or like some way, okay? So what I'm gonna say is I'm gonna take this one 0 because we are keeping delta U. So this is as delta U in the equation. Okay, it doesn't mean that the weight force is not doing work. I'm not gonna include it in my energy conservation. That's what it means because we know that it is non-zero. But if I keep it here and also delta U, then I'm double counting it. That's something I want to avoid, okay? So looking back to this equation then, we have delta K, I'm going to write one more time, plus delta U. That's equal to work term becomes only the work done by tension. Okay, so let's work on this now. Let's do it a little bit more details. Delta means final minus initial, plus again delta U is U final minus U initial, and the work done by the tension force. Let's revise one more time and then see if there's any zero terms. So initially the object had no speed, right? So the initial kinetic is going to go to zero, and the reason I'm writing next to it, make a habit of that, please. VI is 0, okay? You can put all these in the assumptions too, but I think it's nice to show them as you go, so you don't really forget about any of those. It also helps us see why you set them to 0, okay? Hopefully it will prevent you making mistakes if you follow this. We also set the ground level, the bottom level, to be 0y, right? We said the origin starts from there. That means initial potential energy is also going to be 0. Why? Because y initial is set to 0. Okay, so none of the other stuff are 0, so what we need to do is just write the equation for each term. So K final is 1/2 m V final square. Remember, we are trying to find V final plus mg V final. That's equal to work done by the tension force. So what I'm trying to find is the work done, the velocity final, right? And I already have several things, but I like to write things in non-numerical form. So I'm gonna do that quick. V final is, so I'm putting everything, first thing to do is like put this on the right side, and then I need to divide both sides by 1/2 m. That means I'm multiplying right side by 2, dividing by m. But if I rearrange it, this becomes work done by tension minus mg y final divided by the mass multiplied by 2. Again, that 1/2 is multiplied by 2 on the right side. But that gives you v square. So to get v final, you need to also take the square root. Okay, hopefully that's clear. Pause it and take a moment to see what I'm doing if it is not clear yet. And the next step is I'm just going to plug the numbers in. I need to kind of remind myself what work done by tension was. So we used 8480. I think in the solutions I have I carried out more digits. So just to kind of follow that solution on the written form, I'm going to use those values instead, a little bit more accurate. Work done by tension force is 8482.5 joules. Minus mgy final is something we already found, right? That's delta U, and it was 7300. This is also a little bit more accurate than what I showed. More digits are carried, not 2 but 5 joules as well. So that is the top part. We are multiplying this by 2, dividing by the mass. And let me just remind myself, mass is 75 kilograms. Okay, so when you do this algebra, joules per kilogram, what is that? Joules is newtons times meters, right? Newtons is, since think about second law, mass times acceleration, so we already had meters in that, and it is newtons is kilograms meters per second square, and times meters is joules. Kilograms will go away, it becomes meters square per second square, and then when you do that algebra, it will come out as meters per second. That's the unit for velocity, and this should give you 5.48 meters per second. Okay, so that's the final answer, and that's the way you can get it from the energy conservation. You can also do second law and constant acceleration equations, kind of step-by-step process. And it's given in the written form. Since that's not our focus, I'm not going to show it here, but you can definitely check the PDF PDF file to find out how to do that part as well. Okay, hopefully that was helpful.